Okay, so 10.3 is going over the nth term test for divergence. So we're going to talk about a specific test for divergence, and then in the next notes is a specific test for convergence. So the other day we talked about S sub n, and remember S sub n is the summation from n equals 1 to infinity of A sub n. So pretty much that's us plugging in 1, plugging in 2, all the way until we plug in an infinite number, leading us to A sub n. Okay. This says if the summation of an converges, then the limit as n approaches infinity of A sub n is 0. Okay, so if we're given the summation, if we're told that it converges, then we can go ahead and imply that the limit as n approaches infinity is 0. However, if we solve it and we get that the limit is equal to 0, that does not mean that the summation is going to converge. So for this one, this can either converge or diverge. Okay, which means we cannot draw any conclusions if we were just given the limit. Okay, we would need more information in order to determine if it's converging or diverging. So for these notes, we're going to learn about the nth term test for divergent. And this says, if the limit as n approaches infinity of A sub n is not equal to 0, then the summation of n equals 1 to infinity of A sub n diverges. Okay, so if we look at all these summations and find the limit as n approaches infinity, if we get any number besides 0, then we know that the summation is going to diverge. Okay, so these examples says use the nth term test to make a conclusion about divergence for each series. So for the first series, we have the summation, and then we have our A sub n. This whole thing is A sub n. Okay, so what we're going to do is we're going to take the limit as n approaches infinity of A sub n, which is everything above. Okay. And we are going to plug infinity in for n and see what happens. Okay? So notice at the end of these we have plus 1. And we have 3n cubed on the top, 5n cubed on the bottom, and minus 2n squared also on the bottom. Okay? If we plug in infinity, then that means both the top and the bottom, the numerator and the denominator, are going to be approaching infinity. So with that in mind, does the plus 1 do anything to the problem? No, it's not significant, so I can cross that out. Okay. And so really I have 3n cubed over 5n cubed minus 2n squared. Okay, same process. If I already have the 5n cubed on the bottom, okay, and that's going to be approaching infinity, is that minus 2n squared really going to do anything? No. So now I end up with just 3n cubed over 5n cubed. Okay, both of them are n cubed, so technically as they go to infinity, yes, they're both going to infinity there. I can end up just canceling them out, which means I get the limit is equal to 3 over 5. So this goes on back to when we learned about these properties of limits. Okay, because they had the same exponent, we could just say that the answer to this limit is the coefficients in front. Okay. And since 3 over 5 is not 0, okay, this is not equal to 0, then we can say that this diverges by the nth term test. So this statement at the end is our justification. It would probably take off a point or two for the justification part. Yes. However, it's not likely that they'll just have a question like this on FRQ. It'd be multiple choice. Okay, number 2. So looking at number 2, we have the summation of n equals 0 to infinity, and then this is our a sub n this time. Okay. Looking at this summation, you should notice that it should look familiar. Okay. What type of sequence does this look like? Geometric. Okay, so you're going to acknowledge that this is a geometric sequence. And remember, in order to determine if it converges or diverges, you need to look at the common ratio. So our common ratio here is what? 1 over 2. So you're going to say the absolute value of 1 over 2, which is just 1/2, is less than 1. And on the notes for geometric, we said if common ratio is less than 1, then this series is going to what? Converge. So it converges. Okay, so because of all this, we can make that assumption. This is a lot easier to do than going through the process of the nth term test. Okay, so if you ever get something that looks familiar, so you recognize one of these sequences, okay, you need to remember the rules for that sequence and determine whether it converges or diverges. So we're going to learn about a lot more than just geometric. So as long as you have all the rules for each of them, you won't have to show anything. As long as we notice this is geometric and common ratio is less than 1, I know it converges. Okay. Let's look at number 3. Or I can show you what it would look like. Let's say if you were trying to solve it using the nth term test. Okay, that would be the limit as n approaches infinity of a sub n. Remember that a whole thing is that. Okay, this would be saying infinity is going here. Okay, so we have 1/2 to infinity. That's the same as saying 1 over 2 to infinity. Okay, which means as the denominator increases rapidly, that whole part is going to approach 0. So really, this is 3 1/2 to infinity, which is 3 times 1 over 2 to infinity, which is 3 times 0, which equals 0. Okay, which means if we were to do it this way, using that nth term test, we got a limit that equals 0, which means we can't draw a conclusion. We can't say if it converges or diverges. But because we recognized it was geometric, we were able to apply those rules, okay, use that extra information to confirm that the series converges. Okay, so if you were just using the nth term test, technically this would be no conclusion. Okay, that would not be accepted because this is geometric. You have to know all the different sequences. Okay. Okay, another good example is number 3. Okay, notice we have the summation as n equals 1 to infinity of 1 over n. Remember, this entire part is a sub n. We're doing the limit as n approaches infinity of a sub n. So that means n is infinity. So as the denominator is rapidly increasing, that means that entire part, 1 over n, is going to approach 0. Okay. We look at this a sub n. Okay, it's not geometric. So we're not able to bring in that extra information, which means since we have a limit equal to 0, we can't draw any conclusion, so no conclusion. Okay, that no conclusion means it could be either divergent or convergent. Okay, we just need more information. Okay, any questions so far? And if you missed notes 1 and 2, definitely go back and watch those. You need that for this notes. Okay, number 4, we have the summation of n equals 1 to infinity, and then we have the following. This is our a sub n. Okay, so before we start finding the limit as n approaches infinity, we can go ahead and manipulate a sub n and rewrite it. So instead of having those exponents add, let's separate them and give them each their own base. Okay, so for example, 2 to the power of n plus 2 would be 2 to the n power times 2 squared. Notice that's the same thing. Okay, I just gave them each their own base. Okay, same on the bottom. This is 2 to the n power times 2 cubed, and then just bring down that plus 1. Okay. So if we were to do the limit as n is approaching infinity, again, would that plus 1 be significant in any way? No. Okay. So that plus 1 is gone, and now if we look at both the numerator and the denominator, can we cancel anything out? The 2n. Okay, which means the limit as n approaches infinity is going to be left with those constants that are left over, those coefficients. So we have the limit as n approaches infinity of a sub n is equal to 2 squared over 2 cubed, which is 4 over 8, which is 1/2. Okay, again, we were able to cancel out 2 to the n power because technically that's infinity over infinity. Okay, they're the same. I cancel them out. Okay, since this is not equal to 0, then I can say that this series does what? Diverges. So I say diverges by the nth term test. Okay, have to include my justification. Okay. Number 5, the last one. Yeah, last one. Okay, so for number 5, we have the summation of n equals 1 to infinity of e to the 4n over 3n. So again, this is our a sub n. If we were to take the limit as n approaches infinity, what's going to happen with the numerator and the denominator? They're both going to get bigger, right? So they're both going to approach infinity. So this leaves us with the limit as n approaches infinity of a n is equal to infinity over infinity. Okay, that should look familiar, which means we have to use what rule? Yes, L'Hopital's rule. Or, yeah, L'Hospital, yep. Okay, and what does that rule state? We can take the derivative of the numerator and the denominator and then do the limit as n approaches infinity again. So doing that, we have the limit as n approaches infinity. The derivative of e to the 4n is 4e to the 4n, and the derivative of 3n is just 3. So now when I plug in infinity, the only one approaching infinity is which one? The top. So we have infinity divided by 3, which is infinity. And since infinity is not 0, we say that this series diverges by what? By the nth term test.